Hi, welcome back. This is Chapter 7, Chemical Quantities. We first need to talk about what a mole is. A mole is a unit of measurement in chemistry. Pretend that says measurement right there. 1 mole refers to 6.02 times 10 to the 23 particles. And you need to know that that number, that specific number, is also known as Avogadro's number. So 1 mole can refer to many things. It can refer to an atom, such as a sodium atom, or a molecule like the water molecule, or an ion like the chloride ion. So if I'm saying 1 mole of water, how many particles are there? Well, that's just 6.02 times 10 to the 23 particles of water. So let's take an example. 2 moles of sodium, good old sodium. If we convert that, we want to figure out how many particles are in 2 moles of sodium. Simple dimensional analysis with 1 mole and Na going on the bottom and 6.02 times 10 to the 23 particles. I'm just going to abbreviate to parts of sodium, and that's how we get our answer. Now, there are other types of mole conversions that you need to know. So the one we just did was mole and particles. Again, I'm going to abbreviate. The next one we need to know is moles and volume. Mole and volume. So we need to know, you need to know to solve these type of problems that 1 mole of any gas, and it needs to be a gas, any gas has the volume of 22.4 liters. And that helps us out a lot. For example, with this problem right here, 2 moles of O2, we know that O2 is a free floating gas. So it's a diatomic gas. We know that 1 mole, so it's simple dimensional analysis of oxygen is going to convert to 22.4 liters of oxygen. This time I can actually simply solve it out. So let's just do 44.8 liters of oxygen. Simple as that. So we converted from moles to liters. Now let's move on to the next conversion, which is from moles and mass. So for mole and mass, it's really simple too. So let's go back to the previous example of 2 moles of oxygen. Well, we need to find what the molecular weight of oxygen O2 is. So we're trying to convert from moles, or from mole and mass, we're trying to convert from moles to grams. So in order to get grams, you need to know grams per mole, or the molar mass. So if you look on the periodic table, you'll find that 1 oxygen atom is 16. So if we have 2 of them, that is 32 grams per mole. So simple dimensional analysis allows us to convert from 2 moles of O2, and we just simply do 1 mole here and 32 grams here to convert to grams, 64 grams of O2. And that is our answer there. So those are the 3 types of mole conversions: moles to particles, moles to volume, and moles to mass. So the best way to, get familiar with this is practice. So let's do some practice problems. So find the mass of 2 moles of carbonic acid. So when we look at this problem, we need to go to visit our last unit or last chapter on polyatomic ions and naming acids. And you need to figure out what the formula of carbonic acid is. Well, you just need to know You just need to memorize what carbonate is and what happens if we make it an acid, right? We just add hydrogen, so it becomes H2CO3. That is our carbonic acid. So then if we know the formula, we know the grams per mole by using the periodic table. So if we're trying to convert 2 moles, right, of H2CO3, we need to know the grams per mole. So how many grams is in 1 mole? So we can figure out by the periodic table. So 2 hydrogens, that's just 2 grams per mole. Carbon is 12 approximately, and then 3 times 16. So that's 48 plus 12 plus 2, that gives us 62, right? 50, 62, yes, grams per mole. So that gives us 62 here. And you can solve by simply multiplying, and it'll be 124 grams of carbonic acid. So in that example, we went from moles to grams. So that is a mole to mass conversion in that example. So we need to know how to revert back to moles. So these type of problems are where you're given how many moles are in 85.5 grams of, let's say, aluminum sulfate. This time I'll give the formula to you, aluminum sulfate, just like this. You can pause the video to do the problem yourself, but here is the solution. In this case, you need to figure out the molar mass again. So we're trying to convert from grams to moles, right? And the only way through that is our molar mass. So if we just set up the equation here, 85.5 grams of aluminum sulfate, we need to know how many grams in 1 mole of aluminum sulfate. And make sure to always label with units so that you never get confused. So we need to find out how many grams. And we just do that by looking at the periodic table, figuring out the molar mass. So so that should be 2 times 27. That's for aluminum. And I'm not labeling here, it's a bad example, but you should always label 3 times 32 for sulfur and 12 times 16 for oxygen. Hopefully those numbers make sense. The 2 comes from here for aluminum, 2 here. You multiply by 3, so 3 sulfur here. And then you multiply 3 by 4, which is 12, so you get to 12 here. And 27 is aluminum molar mass, 32 is sulfur, and 16 for oxygen. And when you multiply and add all of these together, you get 342 grams per mole. Now it's really easy. It's dimensional analysis. So you go from 85.5 grams to 3 divided by 342. If you just plug that into your calculator, you get 0.25 moles of aluminum sulfate. So in that example, I showed you how to go from a given mass to the number of moles that are existing from that given mass. So that is where I'll leave it off. Next time we'll go over other examples of where we're converting from not mass, but also mole and volume and mole and number of particles.